Today we are going to do section 6.7, where we're going to redefine the natural log and the exponential functions in terms of integrals. What I mean is this. Okay, we are going to pretend that we have traveled to an alien planet where the planet is inferior to our mathematical development in the sense that they just started to develop the natural log. They have not done it the way we did it on Earth. Now, you might remember how you learned the natural log. You learned the normal log, the one that's base 10, and then eventually they tell you, well, you can have any base, but there's a specific base that's called E, which represents the number 2.718, etc. That is very useful. So that's how you learned about the natural log. And eventually, in this course, we have found out that natural log has all kinds of properties, and so on. Now, however, in this new alien planet, they have not done any of that. Okay, they are just now starting with a natural log. So the little alien start talking to you and then says, very excited, that we just discovered a natural log. And you want to say that, oh, we already discovered that a long time ago, but you're not allowed to say that because of the prime directive. You are not supposed to interfere with inferior cultures. And why do I call them inferior? They just started the natural log. What do you expect, right? So you're not allowed to tell them anything. Okay, and then you have to let them develop the natural log by themselves, and they have done it. They have somehow the culture evolved in a different way. So what the alien tells you, the alien student says that the reason they developed the natural logs right now is because of this particular integration, the power rule, which the aliens do know. Okay, well, they didn't develop the natural log. They do know how to do integration. And what they said is this power rule, as you can see, is raised to the power for integration, divide by the power, which is n minus 1, right? Now, there's a slight problem, is that for this formula, n cannot be equal to 1, because if n equals to 1, then you're dividing by 0. So that's what inspired the alien to start the natural log definition, which is that they will simply define this thing right here. Okay, when n does equal to 1, they will define the integration as natural log. And the aliens do know the fundamental theorem of calculus. Okay, and you think, wow, they don't know the natural log, but they know the fundamental theorem of calculus? Yes, they do. Okay, that evolved as to be identical to the Earth version. So that's what we're gonna do. So remember that this formula is exactly where the aliens start. They don't know anything else. Okay, they don't know the exponent, they don't know the rules, but they are going to start developing them. And so you, as the visitor, Earth visitor, will obey the prime directive, not say anything, so that you don't ruin their mathematical development, and watch them develop the natural log in this new way. So the alien is very excited to find this new thing, and he is telling you all about it. Now remember, the alien doesn't know anything about the Earth definition of the natural log. He only goes by this one thing. This is it. This is all he knows, and he will come from there. Now this is the integration of a defined curve. Okay. Now we can draw the curve here, which is also drawn in your book. The 1 over x curve looks something like that. Okay, there is 1 right here, right? And then you will integrate from 1 to x. X may be on this side, whatever. And so then we have so then the alien will look at this equation alone and try to figure out. And for various things he can figure out is that when x is bigger than 1, then it's just the area under the curve, right? And they understand that much. The alien does understand integration, which is why they can design it this way. However, what if x is less than 1? Well, then you integrate backwards. And when you integrate stuff backwards, then it's the same as the negative form. Okay, when you integrate from 1 to x, but x is less than 1, then the same is slapping the negative sign in front. That's one of the rules of integration. So that if you were to integrate this area, okay, say if x is over here, then the number will be backwards. That is, the number will be negative, which corresponds to our own understanding of integration. That if the natural log of a number that's less than 1 is negative. So you are confirming it in your head that their natural log is identical to the Earth version. But again, you will keep your mouth shut and say nothing out of the respect for the prime directive. So then the aliens found that out. And of course, the next thing that the alien notices is the natural log of 1 equal to 0. Okay, by this definition, you're integrating 1 to 1. There's no area, right? You can't open it up. It's stuck together, and therefore the area under the curve is 0, so the natural log of 1 is 0. So pretty good. And furthermore, it is clear that the natural log is an increasing function. That is, as x gets bigger and bigger, you know that 1 over x is doesn't ever go down below the curve, right? So there is no way to get a negative area. It will just increase, very slowly, but it will eventually, each step as x increases, the natural log will increases. Therefore, the next thing the alien found out is the natural log is an increasing function. I'll call that to mean it's increasing. All right, so far so good. Now, next, the alien does know the fundamental theorem of calculus. And being that they know that, then they know one thing. That is, by the fundamental theorem of calculus, the derivative of the natural log, okay, natural log is equal to what's inside, okay, which is equal to 1 over x. This is just a direct quote of the fundamental theorem of calculus. So the natural log, by the fundamental theorem of calculus, the alien has concluded that the derivative of the natural log exists and it equals to exactly what's inside. Furthermore, because the derivative exists, then there's a theorem that says that if the derivative exists, then for sure it's continuous. Okay, that is, the natural log is a continuous function. It's not broken somewhere. Well, at least in this part. Yeah, so at least for when 1 over t is this curve and you're increasing, the natural log is a continuous function. CONT stands for continuous. That's the next theorem. Now, having said that, let's turn the page. So far, the alien's doing pretty good, and everything he says, it corresponds directly to the Earth version. But again, you keep your mouth shut. You don't let it be known that that you know about this. So the alien continues to do a couple examples, being that it knows that the derivative equals to 1 over x, and which is example 6.35, but we will not do it because we've already done it, right? The Earth version does the exact same thing, where you do use the chain rule. So the alien knows the chain rule of integration and differentiation, and therefore he's able to do certain derivatives. But again, you keep your mouth shut and continue, and let alien do his thing. And then the alien next realized that the absolute function where the alien also notices that if you put the natural log in terms of absolute value, because as of right now, the natural log is basically only defined by positive values. And then, but if you do this, just slap the absolute value from here, then even a negative value can be done the integration. And this the reason it can't be negative right away is well, actually we don't even care that much. But the point is, we are including where x is less than 0 by slapping an absolute value in front in such a way that the integral of all values, okay, 1 over u, the du is equal to the natural log of the absolute value of something plus the constant. And the purpose of the natural log is so that we can define for x, when x is negative, we just make it positive and everything comes out. And the reason we have a slap absolute value is because the original definition was defined only for x bigger than 0. Because otherwise the graph has a broken part, and you can't integrate when something is broken. That's why it's defined only for x bigger than 0. But because of but if we slap the absolute value here, then we can define it for all values. That's the where the alien has concluded. So again, you watch all this development with interest, and it's a completely different route from the way you learned it on Earth, but at the same time, it's still parallel to Earth development. So next, there might be some other. So the alien does an integration calculation, which you have already done, example 6.36, and then the aliens they have decided that he's going to investigate the properties of his newly invented natural log. And remember, the alien doesn't know what you know. Okay, so he doesn't know any of the natural log properties. So then he has to develop them from the grounds up, and you can't clue him in. So the properties are theorem 6.18, a couple pages later. The first property of the alien has already discovered is the natural log 1 equal to 0. The second property is the natural log of a product is the same as natural log of the sum. See the second rule, which of course you are familiar with, but he's not. So then he has to prove it. Now how is he going to prove it? And he will prove it by as interesting, a cute little trick. Okay, so then so here's how his proof goes. He will argue that the natural log of say two numbers a times b, okay, which by definition of course equals to just the integral from a1 to ab of the integral of 1 over t dt. So far we are just going directly from the definition. So next step, then he is going to slap on some integral rules. That is, one of the integral rules says that if you integrate from one point to another point, you can always integrate some way in the middle, maybe not even middle, to a different point, and then from a different point to the end point. So the alien decided to integrate from 1 to a, 1 over t dt plus and then a to b. Okay, that's one of the integration rules that you can do this, because integrations is area under the curve. So you do go from some stopping point and then continue counting the area. And remember, a doesn't have to be in between a and b. It can be anywhere. As long as things are defined and reasonable, this will work. And then next, then the alien will, well, this one's fine, but what's happening here? So then the alien will use some kind of a use substitution, which is a clever use substitution to get this to come out. So then the alien let u equals to t over a. Then only this part then becomes, then du, of course, equals to 1 over a dt. And then when you plug all that in, then t equals to u times a. So just this part becomes, okay, I need to transfer the endpoints. Okay, these are the endpoints. So if u equals t minus a, then when t equals to the first one, which is a, then u equals to t equals a, u equals to 1. When t equals to the second point was ab, then u equals to t equals to ab divided by u equals to b. So the integration just for this part goes from 1 to b. And then 1 over t becomes au, right? And then dt becomes a times du. See? So that is t, and that's dt. So then as you can see, this will become just 1 to b, okay, 1 over u du. Now at this point, you notice, what is that? That is, by definition, when you look at this integration, remember the variable doesn't matter. Okay, that fits exactly, equals to the natural log of u. And then this part, so that's that part of the integration. This part, of course, equals to the natural log of a. Again, by the definition of the integral, the alien definition. So then the whole sum then equals to what? So natural log of AB is equal to natural log of A plus B. See? Then the whole thing just comes out, natural log of A plus natural log of B. So the whole thing just came out very nicely in a parallel evolution kind of thing. Okay, they didn't do it our way, but the aliens got it. And the rule turns out to be identical because mathematical rules are universal. Okay, as long as the part of the universe works such that 2 and 2 is still 4, then the mathematical rule doesn't change. Well, of course, if you ever travel to a planet where the mathematical rule doesn't hold, like 2 and 2 might be a million sometimes, then we are going to have a problem. But until then, the mathematical rules work across the universe so far. And so that is how the alien proved part 2 of the theorem, is that the sum of the natural log of a product is the same as the natural log of the individual sums, just like the Earth version. So you're very impressed that they developed the natural log with from a completely different angle. But again, you see nothing, okay, and see how they do the rest. Now we're going to skip part 3 slightly and then go to part 4. And because once we did part 4, as you notice, that part 3, the division is just the same as the power -1. You know, that in other words, a over b is the same as a times b to the power -1. And then once part 4 rule applies, then which says you can take the exponent, stick it in the front, then part 3 will show up immediately, right? So that if we use part 2, because b just have a -1 on top, you slap it in front, it becomes the minus. So then division translates into subtraction. So all we need to do now is prove part 4. The alien way, okay? And again, remember, the alien doesn't know anything about what you already know, and he's just doing this from the grounds up based on his new definition of the property. Now notice that for this theorem, the current theorem that we are looking at, theorem 6.18, it specifically mentions that R is a rational number, not a real number. And the reason for that will be clear very soon. But for now, remember our R, this R in part 4 is only a rational number. It's not a real number, okay? So then, let's see. So let's prove part 4. Now, how are we going to prove part 4? Then to prove part 4, which is part 4, which says that we have to prove the natural log of a to the power r is equal to, just like the Earth version, r times natural log of a. And how are we going to prove that? Let's look at the next page, where it says the derivative of the natural log. We're going to take the derivative to prove something. Okay, so then let's take the derivative. The derivative of natural log of this thing itself is equal to, okay, let's write it down. The derivative of this thing, ln a to the r, is equal to, by the definition of right here from the very beginning, we know the derivative of natural log is 1 over the item. So it equals to 1 over, this is an n here, but it's equal to 1 over the item. Actually, your book have it written down as x. So then we'll do that, because we're taking derivative with respect to x. So we're going to do that way, okay, to be more consistent. So anyway, the derivative of natural log of x, I think this looks confusing. I should write it better. natural log of x. The derivative of natural log of x to the power r, okay, is by this principle right here is equal to 1 over this object, in this case 1 over x to the power r, and then the derivative of this object itself by the chain rule. And the alien does know the chain rule if the function power is if this is a rational number. So they so they figure out the chain rule, which is of course 1 times r x r minus 1, and and then you cancel r with r minus 1 power with the x just r, and then so what you end up with is r on the top and 1x left, okay, because there's this power is less than this one by 1 exactly. Okay, and then furthermore, then you take the derivative of this thing. Now next, we are going to take the derivative of this thing on the right side. So what's the derivative of this thing? So on the right side, we have derivative of r natural log of x. Okay, we're going to turn it into an x to do the variable, and times dx. Well, that is just r times 1 over x. Okay, that is by the definition of again this definition right here. So then, and what does that equal to? That equals to r over x. Now, at this point, you notice that the derivatives are the same. Now, if the derivatives of two functions are the same, that means that by the corollary 2 that we had earlier, that if two functions have the identical derivatives, then in that case, the two functions can only be different by a constant c. So that means that the two functions will be they're identical up to a constant, okay? So that means this one is the same as this one plus some constant. Now, so what constant is that? Now, I'm kind of out of space, so I'm going to write it in here. So we'll write down this fact so far, is that natural log of x to the power r is the same as r times natural log of x plus some constant. So far we have come up with that because their derivatives are identical all the way. So they have to be different by only a constant. Now, what is the constant? Well, to figure out what the constant is, there's a very simple trick, is we let x equal to 1. Okay, why? Because we have already defined right here that the natural log of 1 is 0. Okay, so then, so this is 0. So 0 equals to, that's natural log of 1 is 0, so that's also 0 plus c. So the constant, therefore, is 0, which means these two functions are identical by the difference of 0. So they are identical, period. So that is how the natural log version is proven. Now, so at this point, I want to answer the question, why are we defining r as a rational number only? Why not just say, what's wrong with the real number proof? Because we know that this proof requires that you use the power rule right here, right? And but we know that the power rule is defined for all real numbers. However, the aliens don't know that, and there's a reason for it. And let me show you the proof. Or let me show you the evidence why the aliens restricted this to the rational number, that the power rule, that they only know how to do rational numbers. They don't know how to do the real numbers. The reason they don't know is, here's a screenshot from your book from page 330. And it is the proof of the power rule for real numbers. As you can see, the proof involves usage of the natural log, and the aliens just now developed the natural log, so they can't use it to prove the power rule that that this works. to use this proof, and as a result, their power rule is only up to the rational numbers only, because they don't have the natural log yet. And as a result, so far the alien has come to the same thing as what we know on Earth, except that it hasn't gone to the real numbers yet. So these 4 rules that we have proven, the theorem, it only works for up to rational numbers. Now the next thing the alien are going to do is they're going to define a specific number e such that the natural log of e will be equal to 1. That is, if you plug e in here, the integration will end up being 1, which is same as what you know, okay? But of course, you keep your mouth shut and not say anything. Don't forget the prime directive, right? But you're just there to observe and see how they develop it from a completely different way than what you're used to. So then, what is what is e then? Then the alien decided that when you integrate this thing, okay, being that it goes from 1 to some other point, so then eventually the area will be exactly 1. Down here will be exactly 1, and then whatever that point is, the alien will call that e. Now, there are some things to be concerned. Okay, first we have to be concerned that the number e exists, and then secondly we have to be concerned that the number e is unique, that there isn't another e that gives the same value, because then it will be confusing. Okay, so whether it's unique or not is developed by the fact that the way this graph is, the natural log is increasing, okay? So it can't have 2 values, because if it had a different value, then the different value, the natural log will be bigger, okay? Because it's more area. So there's only one value where the natural log of e equals to 1. So it has to be unique. There's only one that fits. Any more, it will be too much, right? You'll add more area. Any less, it will be too little. So e is, there's only one e that fits. However, the existence of e is not as simple as it looks. The book says you can prove the existence by using the intermediate value theorem. That is, when you as you integrate this thing, get bigger and bigger, and eventually, because natural log 1 is 0 by definition, okay, and eventually you'll get to a big number like 2 or something, right? And then so if it's an increasing function and it's continuous, so if it goes from 0 to 2, it's going to hit 1 sometime by the intermediate value theorem, right? And that is a valid argument except for one thing, okay, that your book has not bothered to mention. But I should mention it because this is only true if it's possible for natural log x to reach 2. How do you know it will reach 2? Maybe it'll never reach 2. Maybe the natural log will hit an asymptote that eventually is less than 2. Eventually it might not even hit 1. So if it doesn't ever hit 1, then e is not defined, because the definition of e doesn't make any sense. And then so far, based on what the alien says, you have not seen anything that says the natural log of x wouldn't hit an asymptote that is at, let's say, 1/2 or something. It depends. Just because it's increasing doesn't mean you'll go to infinity. It could hit an asymptote and never get past 0.5. And your book hasn't paid attention to it, so we'll just assume the alien hasn't thought that far. So then we will keep our mouth shut and just accept the alien's explanation for now, and then just accept that that e exists. Of course, we know that e exists, so it's not a big deal, and therefore we'll accept that e is unique and exists and all that stuff, and then and see what the alien has to come up with next. Now, the next thing the alien decided to do is, being that alien has developed this natural log function in this interesting way, and the alien decided to invent inverse function for the natural log, and the alien will call the inverse function exp. Okay, where exp, being the inverse function, has the property where exp times the natural log not times, sorry, exp of the natural log is equal to x. In other words, it reverses the action. You input x, you take the natural log, then you do exp, it got back to x again. Okay, that's the definition of inverse function. Of course, the other way is true too. Inverse function means if you take the natural log of the exp x, you'll get back. Okay, first that's just the order of things. Okay, whether you take natural log first or exp first, it'll go up, your thing will go back, and that's the definition of the inverse function. Now then the alienness was able to graph the exp, being that it's able to graph the natural log function, is already well defined, and it looks something like this. Okay, as all inverse functions, they're just reflections against the y equal to x line. That's the what do you call it? The 45-degree line across the middle. That's the y equal to x line, and all inverse functions are just mirrors across that thing. Okay, so then the exp, this is so then the alien has an interesting expectation. That is, he figures that the expx must be the same as e of x, where e is defined this way. And now why? Because how does it know that? Now, so far we have only defined things for the rational number. Okay, remember, because the aliens were developing exactly the natural log function that's required to prove the power rule of something that I showed a little earlier. The point is, the alien only has stuff defined up to the rational number. So then for rational numbers of x, exp x, so if it's a rational number, then we have the natural log of e of x. How do we know this? So if x is rational, we have, the alien knows that natural log of e of x, okay, x, which is equal to, by the rules that we just developed, we can take the exponent out if it's rational. So equal to natural log of e, and that is simply x. Okay, so then e of x, which means what? Which means e of x, then so e of x is the same as because see, the natural log of x of this thing is equal to the same thing, which means e of x is identical to the exp of x. But this is only true for rational functions. So what happens when the value is not rational? You have to develop, I mean, it will be a funny function. It's only defined for rational numbers. Well, for irrational functions, then the alien decided, then e of x is just the inverse function of natural log of x. It's defined that way. We simply define it. So that's how they got around the rational bit, and therefore, look at the next page, page 727, where y equal to e of x is to be defined to be the number for which it is the inverse function works out. Okay, natural log of y is equal to natural log of e to the power x, which is just x. All right, so far so good. And so the next part is then the natural log of e to the power of natural log would then, we have e to the x, that the natural log theorem then works properly, see, like that, where e to the power natural log is equal to x, and well, the e is exactly the inverse function. Okay, natural log of e to the power x is also x. All right, and so the next thing the alien's gonna do is figure out the properties of e. Now that the alien has discovered the e to the power x, where e is that specific number, it happens to be the the inverse function of the natural log that is defined earlier, the alien's very excited to find out certain properties of the function e, and then the alien's very fast, of course, to develop these standard properties of the function e, and being that its power is added together and division is the same, and then the third power the same way. Now, how does the alien find that out? Well, the power that applies to regular power rule, except for when p and q, except for when r is a real number, is not a rational number. So then for the except for when p and q are irrational. So then to get around that, the alien will use this property of natural log being a one-to-one function. That is the proof for all the properties. Let's say the first one, which is, let's prove the first property, which is e to the p. I'll write it over here. E to the p times e to the q equals to e to the power p plus q. Is that the first? Yeah, I think so. Okay, so then how do you prove that? Then the alien will use the newly developed natural log function to prove it, and by the definition of e. So the natural log of e to the p times e to the q, where p and q are p and q are irrational. Okay, so then that equals to the natural log of individual ones, e to the power p plus natural log e to the power q. And then that, of course, being that they are inverse functions, this is equal to p plus q. And then that equals to, you get back, that would be equal to the natural log of e to the power p plus q. Natural log of e, right? Okay, which is fine. And then being that natural log is a one-to-one function because it's increasing, then if the results of the natural log are the same, then the origin has to be the same as well. So then, because they're one-to-one, so then EPEQ has to be equal q. It has to just be equal to e to the power p plus q, and that's true for all numbers, not just rational numbers. And that is the similar proof for the rest of it. Now, and then at this point, you realize that the rest of the alien's proof now parallels what you learned. Okay, for example, what is the derivative of e to the power x? The derivative then is the alien then used the inverse, what is it called? The implicit, right? The implicit differentiation, right? So then to figure out what is the derivative of e to the power x, well, let's say y equals to e to the power x. The alien then used the inverse function, which is which we have done, but I guess I'll do it again. And so then the alien says, then we'll take the natural log of both sides. So then the derivative of the natural log of dx with respect to x, doing inverse function now, is equal to, so then natural log of y equals to x, right? By definition, the derivative of natural log of y is just equal to 1, and dy equals to, we'll write this down, dx of x, then the derivative of natural log is 1 over y dy by dx, which is, and this side is just equal to 1 because you're taking the derivative of x, and then from here you get dy by dx equals to y. And what was y again? So what that means is the derivative of y, okay, equals to y itself. That is, the derivative of e to the power x is e to the power x. And that is the end of the proof of what the derivative of e to the power x is. Now, if you flip over a couple pages to 720, page 729, then eventually, then the alien will take care of the rational power problem, then rational number by defining one last thing. Okay, that is, what is y equal to a to the power x? Then the a to the power x is defined as e to the power x natural log of a, and by then the entire all the properties or proofs of that function is completely identical to what we've already learned. So we don't have to so I'm not going to talk anymore about it. So because at this point, the alien's evolution has joined the Earth version, so everything's identical, just like what we've learned before. Because the natural log function has been defined enough, so it reached our point. So the rest of it, I'm not going to go over because we've already talked about this earlier. And that marks the end of the section, I believe. Yep. I'm not going to have you do any examples or homework in this part because they are identical to the Earth version, right? We're doing this section just out of interest to see how the alien planet was able to develop the natural log in a completely different way. I mean, this is basically where we end up, right? Eventually, we realize the natural log of x is the integral, whereas they started that way. But even then, you notice that the two cultures ended up in the same point because mathematical rules are universal. So this is just a chapter of matter of interest, and you're not learning anything new for the natural log because we already gone through all of this stuff, and therefore we can finish this section without worrying about homework.